Hello everyone. We have understood how we can get DC from AC, and we have understood the DC power supply through the block diagram. And in this video we are going to understand, and we are going to open one charger. I have taken one old charger, so let us, without any delay, let us start the video. So this is the old charger that we are taking today. So we can see here is, from here we this we apply to the phone, and we get the DC from here. The output is we get the output. This is applied to the phone, and here this one is the input of the charger. So let us now open it. So you can see, so input, these are the input here. Okay, so the input we can see here, these two metallic contacts, here one and here it is one. Okay, here you can say it is written N for neutral and L for line. L for line means it is connected to the positive terminal, and for neutral means it is connected to the negative terminal. Okay, negative is generally we see red and black wires. So red wire is for L, and the black wire, that is neutral, it is for N. Okay, so here you can see VRI means variable resistor. Okay, varistor. And this is fuse. You can see here it is written here F1. Okay, so what is the purpose of fuse? Fuse can it can melt. It is the main purpose of the fuse is to protect the all circuit. Okay, if the high voltage or current, if high current is coming, then it will melt and it will protect the whole circuit. Here you can see this is the basic component. Here are the basic components. Here C1 written, C1. Okay, C for capacitor, this is electrolytic capacitor. Here is also, you can see, this is C3, this is also capacitor, and this is ceramic capacitor. Here C2. Okay, this is also capacitor, and there CY1, this is also capacitor. And this yellow component, you can see here is a big component, yellow component, this is a transformer. Remember, when we were talking about the DC power supply, we were saying there is the transformer convert the high current into low current. Okay, it is for the conversion. We are high voltage or high current to the low voltage to or the low current. Here you can see it is written TRF. Okay, it's written TRF. So this is transformer. Okay, basically you can see, if it is specifically, this is ferrite core transformer. This yellow stripe component is ferrite core transformer, and this is free of. Why we use ferrite core transformer? Because there is no ED current loss in ferrite core transformer. Okay, so this is the ferrite core transformer. This is another capacitor, and here you can see V plus and V minus. So if we flip this, here is the output that we are getting. Okay, output we are getting. So if we flip it, here you can see the V plus is here and V minus is here. Okay, so from here we get the output. And the other devices, if you want to see, here BD is written. BT is the bridge rectifier. So what is the purpose of bridge rectifier? Bridge rectifier is actually converting AC signal into pulsating DC. Okay, and here U is the transistor. U is the IC, here IC. Okay, and here more components are here, like here D, you can see D for diode here. Okay, D1 is for diode. Here the other components are also there. Here R1 is the resistor, R2 is the resistor, U1 is the IC, and BD is the bridge rectifier, and here diode. And from here red and white wire, from here we are taking the output. You can also see this white part is east, means this is non-conducting. Here they have made the two sections here. Okay, so from this part again we can revise. Okay, this through the metallic part, from the metallic part we are getting the input, and this input, the fuse is here for the protection. Okay, and this is the capacitor is the what it is the for filtering. Okay, for smoothing out the ripples. Okay, these two are also the capacitor here. And this yellow part, yellow component is the ferrite core transformer, step down transformer. Okay, from V minus and V plus we are getting the output. Okay, and here BD is the breeze rectifier, and this IC U1 is the IC, and registers are also there, and there is the diode. So this is all we have in this video. See you in the next video with some interesting thing. Till then, bye.